I made a machine learning algorithm. Alright, the idea is we take 100 images, 50 yellow flowers, 50 purple flowers. They also have different shapes. These 100 images, the algorithm reads it. It transforms the images into data. The way I've done it is just I have turned the pixels into RGB information, like, RGB, how it works, red, green, blue. So basically the images are downscaled. Also, they are reduced in size. The quality is pretty terrible. I will show it. The point of this is to get the essential data from the image, trying to take out as much redundancy as possible. There comes a point in an image when doesn't matter how big it is. Like you see an image of a house and you ask yourself, how small could this image be so I still can tell it's a house? So the machine learning algorithm works the same way. There will come a point where an image can be gigantic in resolution, but it's not going to change the accuracy of the algorithm because there's a lot of it's just redundancy. So what this thing does is it takes all this data and then creates the one versus all algorithm of logistic regression. It does gradient descent over and over. Like I think it's just 6 times. I tested it and around 3 times was already converging. You could think of it like geometry in x dimensions and then looks for global minimums with a cost function that is related to the problem we are trying to solve. So in this case, the cost function represents how close is the machine to correctly tell that a flower is yellow or purple. And with that in mind, with that goal in mind, we try to minimize the cost and with all this data. I think that's the most quick explanation I can do. This is very complicated. I created this variable. I can change it, and this just means the image I'm working on in the training set is 40 by 40 or 50 by 50, whatever. And that represents directly with the amount of features this problem deals with, because the amount of the pixels are the data I'm working with. So the results are the following. With 20 by 20, this is the amount of pixels, 20 by 20, 30, 40, blah, blah. So we're with 20 by 20 in the training set, 84%, 20, then 87%, then 40, 90%. This is when I was, oh yes, 90%, great. But then in 50, 87%, sorry, 7%, and with 60, 89%. I realized here that it comes a point in the training where it doesn't matter how big it is, it's just redundancy. So I took the value of 40 by 40, and I said, okay, that's going to be the optimal. And I ran the test with 40 and I got 61%. But then I tried 50, I got 60%. This isn't the test. The test is the new pictures that the machine has never seen, and there is trying to classify into yellow flowers or purple flowers. So this is a pretty good result, 70%, at least by my standards. It's the first time I do this. Then 73%. And I decided to stop here because the machine was getting slower and slower, I mean, it's pretty fast. It's like 30 seconds, a minute. But I wanted to do something simple. I didn't want, with this kind of algorithms, when you work in deep fakes or things like that, people spend hours and hours just training the algorithms because they're using a lot of features. Like when I'm using 60, 10,000 features, because we got 60 by 60 by 3. So 10,000 features, it means that the matrix, it's 10,000 matrix by the amount of samples, so by 100. And that's the size of the matrix. I'm applying mathematical operations to it. Gradient descent is, at the end of the day, is a lot of math. So the bigger this matrix is, the slower the algorithm becomes. So you gotta be careful and just try to look for an optimal value. In this case, 50 would be the optimal in my opinion, because it's like it's more or less where everything plateaus, both the training set and the test set. There's a reason why I believe this is not better. The data conversion from the image algorithm is not perfect. I think I missed a channel, maybe the alpha channel or something, and some images are not the right color or they're corrupted. I mean, I'm showing some examples. After this, I would try to make a neural network and try to see if I can get even more features with less time. Yeah, okay. I think that's about it.